Students, yesterday we were discussing about the Python object-oriented programming concepts. So as part of that, yesterday we discussed how to um, pass objects as arguments, then how to receive objects from a function, then how to copy one object to another object, and also at the same time yesterday we saw one simple example of how to use copy module. Students, tell me what is the purpose of using copy module? Hello, students, tell me what is copy module? Hmm? Students, tell me about copy module. Hello?
Sir, it's a set of functions that related to copy different elements in a list, sir.
Hello? Tell me once again.
Like objects are sir, it's a set of functions. It's related to the copying elements, copying different elements of a list, sir. Like example, objects, arrays, like and create the copies of another elements.
So simply you can tell a copy is a function which is also defined in copy module, which is useful to copy one object to another object. Okay. Now what
Okay,
happens
sir.
when you copy using one object to another object? What happens? So what is the difference in copying directly without using copy method and by using copy method? What is the major difference? What happens if you do not use copy method? If you do not use copy
Otherwise, we,
method,
we have to create again.
no, I am asking what is the difference? See, we can copy one object to another object just like by using copy constructor, just like how we do. So say for example, object C3 is equal to C1. Contents of C1 will be assigned to C3 like that. Like that also here we can copy without using copy module. But what happens if we copy without using the copy module? Both the objects will be having the same memory location. Both objects will share same memory location, and at the end there will be only one copy of the object, isn't it? But if you want two different
Yes,
copies
sir.
with different physical address, then we have to use copy module. When you use copy module, you can see here, students, p3 import copy. See here we have created a class point, then we have created object p1. Under p1 we have created p1.x and p1.y. What kind of attributes are these? These are instance attributes. Now importing copy module, then copying copy of p1. So here this first part, copy is the name of the module, and this copy is the name of the method used to copy contents of one object to another object. Now we are copying. Now if you try to display the address of two objects p1 and p3 separately, you can see here this is the address of p1 and this is the address of p3. Both are totally different. So this is the advantage. You can maintain two separate copies. So that means we are creating one duplicate object. In the previous example, see here directly we are copying. See here we are creating object p1 and creating the attributes x and y and assigning the values. After that we are copying p2 is equal to p1. Now if we display the contents of p1 and p2, you can see both are same. This is the address of p1 object and this is the address of p2 object. And look at the object diagram. So this is the object diagram. See here we have P1 and P2, both are pointing to same values. This is the object diagram. Now look at the object diagram when we copy by using copy module. See, you have P1. This is having a separate copy of attributes X and Y. And here look at P2. This is also having its own copy X and Y attributes. But the values are same. Because why the values are same? Because we are copying the attributes of P1 to P2. You can see here what is there in P1, same thing we are copying to P2, and here also Y value, what is there, same thing we are copying to P2. Hence the values will be same, but the physical address is different for P1 and P2. Okay students, so this diagram is very important. Okay, this gives you the clarity. So it maintains separate copy for P1 and separate copy for P2. Students, this kind of copy is called as shallow copy. In Python, there is a concept called as shallow copy. So shallow copy means when you are copying the object using copy method, it will copy the values of the object as it is without any change in their values. But as an object, both the objects will point to different memory locations. This kind of copy is called as, once again I repeat, shallow copy. Okay, yeah, somewhere here I have told, yeah, somewhere here it is being given. This concept is called as shallow copy. And here one thing you need to understand. See, the copy method of copy module duplicates the object. The content, that is the attributes of one object, is copied into another object, as we have discussed till now. But when an object itself is an attribute inside another object, the duplication will result in a strange manner. To understand this concept, try to copy rectangle object as given below. See, we did this rectangle, how to find the midpoint of a rectangle. So look at this program, then we'll see how to implement copy module for this program. Then we'll see. So then we'll demonstrate the concept of shallow copy. So importing copy module, because I want to create the duplicate object with a different physical address. Then here, see, we know that this class, this represents a class in a coordinate system, and this class rectangle, which represents an geometrical structure rectangle with attributes width, height, and corner point. And remember students, this corner is one of the attribute of rectangle, but at the same time this is also an instance of point. Okay, at the same time this must be an instance of point. Why? Because this represents an instance of point, and point represents, okay, it's a class, it's a point in coordinate system. This represents coordinate system. Now box 1 is equal to rectangle. So this is an box 1 is an object of rectangle, and for that rectangle, okay, look at here, this corner is also an attribute. Okay, so box 1 dot corner, that is fine. At the same time, look at here, there must be an okay, one object is copied to another object. Okay, but when an object itself is an attribute, inside another object, okay, this, now look at here, box dot corner is equal to point. Now this corner has become an object of point, but at the same time corner is also an attribute of rectangle. So now in this situation, what happens if we apply copy? Okay, see, width and height are normal attributes, that is not an issue. Here we have, as part of rectangle, we have three attributes: width, height, and corner. First two are normal attributes. Okay, nothing happens. But this is an instance of point class, some other class. Now how it will copy, let us see. Now box dot width is equal to 100, initializing attributes, width and height, and at the same time this itself has two other attributes, x and y. See, now the corner has become an object of point, therefore it can have its own attributes. Now, so I am assigning corner dot x is equal to 0 and corner dot y is equal to 0. Now we are applying copy function. Box 2 is equal to copy dot box 1 of, sorry, copy of box 2 is equal to copy dot copy of box 1. That means box 1 is the already existing object which has three attributes in it. That is box 1 dot corner, box 1 dot width and box 1 dot height. In turn, this corner contains two more attributes, x and y. Okay. Now let us see how it will copy. Now if I check, box 1 is box 2. Students, tell me what is the reason it is displaying false? I want the reason, students. Tell me why this statement results in false. Anyone? Arjun? Abhinav? Manisha? Yeah, Arjun, tell me why this statement results in false.
Sir, Arjun, sir. Sir, in a Python, it's a diff in error. It shows because there is no assignment or comparison between objects.
Here, what it checks is, it checks the physical address. Is the operator always check the physical address that both are pointing to the same memory location or not, be box 1 and box 2. But here we are copying by using the copy method, for therefore both will be having different physical existence, hence it is returning false. But if you check, box 1 dot corner is box 1 dot corner. So what is this corner? This corner is an instance of the class point. That means this points to the address of point, and this also is pointing to the address of class. Hence, this prints true. So this is what you need to understand in shallow copy. Okay, later explanation is been given here, but I'll read. So now the question is, why box 1 dot corner and box 2 dot corner are same objects when box 1 and box 2 are different? Whenever the statement box 2 is equal to copy dot copy of box 1 is executed, the contents of all attributes of box 1 object are copied into respective objects of box 2. Okay, I'll show you the diagram. Look at here. Look at here. This is box 1 and this is box 2 object. So width is copied from here to here as it is. Width is equal to 100. Width is equal to 100. Here one more attribute. Height is 200 and here also height is 200, and a corner object. Okay, so when it comes to corner object, it is not maintaining its own copy. See here, you can see this point object. So this is a point class, and this x and y are shared between both box 1 dot corner and box 2 dot corner. So the reason, I'll read out the reason here. Similarly, see here, that is box 1 dot width is copied into box 2 dot width. Box 1 dot height is copied into box 2 dot height. Similarly, box 1 dot corner is copied into box 2 dot corner. Now recollect the fact that corner is not exactly the object itself, but it is a reference to the object of type point. Okay, so this is not exactly the object, but it is a reference to the object of type point. Hence, the value of the reference, that is the physical address, stored in box1 dot corner is copied into box2 dot corner. Okay, hence the value of reference stored in box1 dot corner is copied into box2 dot corner. Thus, the physical object to which box1 dot corner and box2 dot corner are pointing is only one. This type of copying the object is known as shallow copy. Okay, so that means here this was containing the physical address of point, and so same thing is being copied into this object, and as the result both are pointing to the same memory location, and this kind of copy is called as shallow copy. Okay, so that means if you get a question, demonstrate the concept of shallow copy with the help of suitable example, then you have to take this example. So this rectangle program where you copy this corner object. Okay, so this example you need to consider. So there is one more variant of copy that is called as deep copy. Now the attributes width and height for two objects box1 and box2 are independent. Okay, now so these two are independent objects. Here this height and width are independent. These two attributes belongs to box1, and here another set width and height is there that belongs to object b2, so that becomes independent. Thus any modification done to box1 dot corner will also reflect in. Okay, so now look at here, whereas the attribute corner is shared by both the objects, thus any modification done to box1 dot corner will reflect to box2 dot corner as well. Obviously we don't want this to happen whenever we create duplicate objects. This is, that is, we want two independent physical objects. Python provides a method called as deep copy for doing this task. This method copies not only the object but also the objects it refers to and the objects they refer to, and so on. So students, now what happens in this example? Now this corner object is being shared between two classes, box1 and box2. That means if you do modifications to box1 dot corner dot x, that is also applicable to box2 dot corner dot x, and similarly if you do modification to box1 dot corner dot y, so that is also applicable to box2 dot corner dot y. To overcome this, that means just like how you have width and height exclusively for box1 and box2 separately, similarly if you want to have this x and y separately for box1 and box2, then you need to follow deep copy. So that is one more concept, deep copy. So look at here, deep copy, how to implement deep copy. Box3 is equal to copy dot, instead of copy just type deep copy of box1. Box1 is box3, false. Box1 dot corner is box3 dot corner. Now this is, look at here, now the outcome is false. Why? Because now this will, box1 dot corner will occupy different physical address than box3 dot corner. But in the earlier example, look at here, both were occupying the same physical address, hence it was showing true. Look at here, it was showing true here. Now after deep copying, what happens? Box1 dot corner will occupy a different physical address than box3 dot corner, hence it is returning false. Thus the objects b1 and box b3 are now completely independent. That means, so therefore students, always it is better to use deep copy rather than shallow copy. If you use shallow copy, what happens? So like this, objects will not be copied. Like this, objects will not be copied. Okay, so only one copy will be shared across both the objects. As a result, if you do modifications to one object, that is also be that will also be reflected in another object. So if you assume this as the drawback, if you don't want to share these values, if you want to have independent corner object for box1 and box2, then you need to follow deep copy instead of shallow copy. So students, this that's an interview question. Differentiate between shallow copy and deep copy. You go to any Python interview, that is a common question. Differentiate shallow copy and deep copy. So the major difference between shallow copy and deep copy is that shallow copy can copy only the normal attributes but not the reference to some other class. So it will fail to copy the reference to some other class. To overcome this drawback, we have to use deep copy. Whereas this deep copy will see that both the objects will maintain the separate individual copies of uh, reference reference objects as well as data members. So here width and height are data members and this corner is the reference variable. This is a reference variable to point class. Students, anything you want to ask here? Deep copy with respect to deep copy and shallow copy. Hello? Students, anything you want to ask? Shall I continue? Shall I continue?
No, sir. Yes, sir.
Okay, now let us see how to debug.
Yes, sir.
Like, let us see what kind of small errors can come while debugging the program. While dealing with classes and objects, we may encounter different types of errors. For example, if we try to access an attribute that is not there in the object, then let us see what kind of error will come. So we'll get an error that is attribute error. Now look at here, we have object P and we have two data members X and Y. So these are called as instance attributes. Now if you are trying to print p.z, which is not at all there, it will result in an error. Look at here, this is the error. Attribute error, point object has no attribute z. So how to overcome these things? To avoid such error, it is better to enclose such codes within try and except block as given below. Look at here. Try z is equal to p.x except attribute error. Okay, z is equal to 0. If this assignment fails, then it will assign z is equal to 0. So when we are not sure which type of object it is, then we can use type. Okay. Say for example, you have an object, but you don't know. Say many times what happens when you are doing programming at project level, you may be using so many objects in one particular class, but sometimes you get confused. Oh, this belongs to which class? Then just you can examine by using this statement type of object name. Okay, just if you include this one statement type of object name, it will show you. Okay, it will give you the clarity. Okay, it belongs to which class. Then if you want to check, say for example, you may be thinking that box is an object under class, but still you have a doubt. Okay, so whether it is true or not, if you want to examine that, there is a method called as isInstance. Helps to check whether an object is an instance of a particular class or not. IsInstance accepts two parameters, name of the object and the class name. See, now you are thinking that box1 is an object of rectangle. So then you pass box1 and rectangle as parameters. If it returns true, that means yes, box1 is an object of rectangle. If it returns false, box1 is not belonging to rectangle object. Okay, that's the outcome. That's the conclusion. When we are not sure whether an object has a particular attribute or not. Similarly, you can check whether the width attribute belongs to box1 or not. Okay, if has attribute, that is has attr, this is called as has attribute function. Has attr, that is attribute of box1 comma width. If this returns true, that means width is an attribute of box1 object. If this returns false, that means width is not an attribute under box1 object. Okay, that's the meaning. Students, got it? The purpose of using isInstance and has attribute. Hello?
Yes, we got.
What is instance?
So like while we are checking to it's a particular class or not.
Yeah, that means you
We
have an
do.
object with you. You want to cross check whether
Yes,
it
sir.
belongs to the class what you think.
Particular.
Yeah.
Yes, sir.
So if it returns always the Boolean value, true means yes, that object belongs to that class. Otherwise, no.
Yes, sir. False means it will not.
Yeah. What is has attribute function?
Like we are not getting that it belongs to particular or not.
No, no. You have an attribute with you. So you want to check whether it belongs to that object or not. Say width belongs to box 1 or not. So box 1 is one object. You want to check whether it belongs to box 1 or not. In such situation, you can use this
Yes, sir.
statement. Observe that string notation for second argument of the function has attribute. Though the attribute width is basically numeric, while giving it as an argument, it must be enclosed within double quotes. See, now width is an attribute. Okay, even though this represents some numeric value, always the second attribute must be encoded within single quote or double quote, because this will be considered as a string. Students, keep in your mind, the second parameter must be always encoded within either single quote or double quote. So the Python interpreter understands this as an string value. Okay, now classes and functions. So classes we know. So functions are called as methods here. So in Python there are two types of functions, pure functions and modifiers. Students, any idea what are pure functions and modifiers? I think you have studied pure virtual functions in C++, but you don't know what are pure functions. Okay, now I'll tell you. So when we write any function or a method in Python, we categorize them into two types. That is whether they are pure functions or modifiers. Okay, now let us assume we are writing a function and we are passing some arguments to the function, and in the function definition, if 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 those argument values originally what you have sent, say for example, let us assume you have sent two arguments x and y, x is equal to 10 and y is equal to 20. If the original values x is equal to x and y values are not at all altered in the function definition, then we assume such a function as pure function. Okay, if the x value is getting changed in the function definition, say for example, so x is equal to x plus 1, that means the original value of x which was 10 is becoming 11, so that is getting modified. Okay, then such a function is called as modifier function. Got it, students? There are two types of functions, pure functions and modifiers. A pure function takes objects as arguments and does some work without modifying, okay, does some work without modifying any of the original argument. On the other hand, as the name suggests, modifier function modifies the original argument. Okay, in practical applications, the development of a program will follow a technique called as, okay, that we will see, prototype and patch, that we'll see later. Okay, students, now let us see the example for pure functions. To understand the concept of pure functions, let us consider an example of creating a class called time, and object of class time contains hour, minutes and seconds as attributes. Write a function print time in hour, minutes, second format, and another function to add two time objects. Note that adding two time objects should yield proper result, and hence we need to check whether the number of seconds exceed 60, minutes exceed 60, and take appropriate action. See, that means here we are writing a program to add two time objects. So each time object has three attributes: hours, minutes, and seconds. Okay, and this is the format of time. Okay, now the aim of this program is to create a class by name time with attributes hour, minutes, and seconds, and we need to create two objects t1 and t2, which represents time and having the attributes hours, minutes, and seconds. And we need to see that so appropriate action will be taken when the minutes exceeds 60 and the seconds exceed 60. Okay, appropriate action has to be taken. Then, very importantly, the contents of T1 and T2 should not be altered because we want to demonstrate them as pure functions. So now look at students. I am creating a class time. Then, so look at the main function. So this is a main code. So T1 is equal to 10, creating one time object, initializing the attributes of T1. Hour is equal to 10 hours. Minutes is equal to 34. Seconds is equal to 35. Then here print of print time of t1. That means I am sending this object as an parameter to print time function. Look at here, where is print time? So this is not making any changes to the attributes of t, isn't it? It is displaying as it is. Percentage dot 2d, percentage dot 2d, percentage dot 2d, that will be replaced with percentage of t dot hour, t dot minute, and t dot second. That means we are not modifying anything. We are displaying as it is. Look at here. Look at here. We are displaying as it is. So therefore, now print time is a pure function. Now print time is a pure function. Why? Because it is not altering the contents of the receiving object. Similarly, let us check. Similarly, create one more object t2 and initialize its attributes. Hours is equal to 2 hours, minutes is equal to 12, and seconds is equal to 41. Print time, once again we are passing another object t2 as a parameter. Once again it will print as it is. It will print what is the value of hour, time, and seconds. So look at here, it is displaying as it is. So therefore, once again we are reassuring that this print time is a pure function. Then now we want to add. Now here we are passing two parameters to add time function. So add time is a function. Okay, t3 is one more object. T3 is equal to add time of t1 comma t2. What is t3? T3 is one more object. Okay. Now what happens here in add time? Look at here, receiving t1 and t2, and to store the sum we need one more object of type time. So I'm creating one more object sum. Okay, see students, actually sum is a keyword in Python. You should not use sum. So I'll make it as sum1. Okay, wherever sum is there, I'll make it as sum1 because it's a general guideline that we should not use keywords. Okay, I'll make it as sum1. Okay, so now look at, okay, now let us see. Sum1 is equal to time. So this is a resultant object to store the sum of t1 and t2. We have created this sum object. Sum1 dot hour is equal to t1 dot hour plus t2 dot hour. So now you can observe here, this t1 dot hour is not getting modified. Similarly, t2 dot hour is also not getting modified. Just we are adding them and we are storing it in sum1 dot hour. Similarly, sum1 dot minute is equal to t1 dot minute plus t2 dot minute. So here also minute attribute is not getting modified. Similarly, sum1 dot second is equal to t1 dot second plus t2 dot second. That is not getting modified. So now, but you can see here, if sum1 dot second is greater than or equal to 60, then sum1 dot second is equal to sum1 dot second minus 60. Okay, so that means whatever the changes that are happening, that is happening to resultant object, that is sum1 object, not to t1 and t2. Similarly, sum1 dot, if sum1 dot second is greater than or equal to 60, sum1 dot second is equal to sum1 dot second minus 60. So we are updating the values. Then similarly, so now the minute should become, say for example, 10 minute. Okay, say for example here, the seconds become 65. Okay, then you should subtract it with 60 and you need to increment minute by 1, because after every seconds the minute will get 1 increment, isn't it? See, once okay, once it crosses 60 seconds, okay, the minute will get 1 increment. Similarly, if sum1 dot minute is greater than or equal to 60, then sum1 dot minute is equal to sum1 dot minute minus 60. Then we need to increment the hour. So why? Because after 59th minute you will get new hour, isn't it? That's why. So if it is greater than or equal to 60, you need to increment sum1 dot hour by 1 count, then return sum1. So even in this method, we are not modifying the contents of t1 and t2. Even see, in print time we have two functions. Print time, here also we are not modifying the contents of the receiving object, and here also we are not modifying the contents of receiving object. All the modifications are happening to this, the local object, whatever we have created inside the function. So therefore add time is also a pure function. Okay, whatever the functions that we have written here, all those functions are pure functions. They are not making any attempt to change the contents of receiving object, hence they are called as pure functions. We will see modifier functions in the next class. We'll take the attendance. USN 1,
Yes,
Asta
sir.
Bachawat.
Yes, sir.
USN 2, Abhinav. USN 3,
Present, sir.
4,
Yes, sir.
5,
Present, sir.
6, Arbaz Khan. 7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13, Deba Malya. 14,
Present, sir.
16,
Present, sir.
17,
Present, sir.
18,
Present, sir.
19,
Present, sir.
20,
Present, sir.
21. Harshit. 22.
Present, sir.
23. Kavya. 24. Kishore. 25.
Yes, sir.
26. Manisha. 27.
Yes, sir.
28.
Present, sir.
29.
Yes, sir.
30. Nishant. Now TD series. USN 2.
Present, sir.
3. Maithili. 4.
Present, sir.
5. Pawan.
Present, sir. Present, sir. 5 present, sir.
6.
Six present, sir.
7.
Present, sir.
8.
Present, sir.
9.
Present, sir.
ಹಿಂದಾಕ್ಲೆ
10.
Present, sir.
11.
Yes,
Sir,
sir.
10 present.
12. Rizwan. 13.
Sir, B wise.
12. Sir, 12 present.
What you are doing, man? 13.
Network disturbance.
13. Vishal. 14.
Yes, sir.
16.
Present, sir.
17. 18.
Present, sir.
17. Sneha absent. 19.
Present, sir.
20.
Present, sir.
21. Sunil.
Sir, present, sir.
22. 23.
Present, sir.
Sir, Kavya's network issue, sir. She's telling,
Okay.
sir, but you are not hearing.
Okay. 23. Vinirana. That's it, right? Students, today we discussed about how to copy the objects with and without using copy. Then also we came to know the difference between shallow copy and deep copy. That is, the disadvantage of shallow copy is that it fails to copy the reference objects. To overcome that drawback, we have to use deep copy. So when you apply deep copy, it will create two totally independent objects. Even if it is having reference objects also, that will create independent copies for both the objects. So that's why it is called as deep copy. So after deep copy, we discussed about pure functions and modifiers. So pure functions are those which will receive the arguments, and it will not make any attempt to change the original content of the argument. It will retain the original content of the arguments as it is, hence they are called as pure functions. Whereas the modifiers will modify the original arguments that you are sending as parameters. Okay, that example we will see in the coming class. Okay, that's all we discussed today. Okay, anything you have? No, instead of quiz today, okay, you need to write one program. Okay, apart from what is given here, deep copy. To demonstrate deep copy, you need to take one example and you need to execute and submit the results in GCR. You have to take your own example apart from what is explained now to demonstrate deep copy. And okay, at time I'll give up to tomorrow. Sunday also you have enough time. By tomorrow end of day you have to submit that assignment. Example for deep copy. Got it? So now I'll create one assignment. I'll create an assignment. You submit it by tomorrow end of the day. Python program to demonstrate deep copy. So I'll create the assignment here. It is not like one student will write the program and everyone will copy. I expect the examples will be unique. Students, remember, it is not like one student will write some program and all others will copy. I expect each program is unique. Okay, try to assume your own example and make it as a program and post the results here. Due date tomorrow I'll give. Sunday 22. Yes, by 22nd you can submit.